Alright, in this video we're going to talk about Unit 2 Objective 1 Power Rule. So this is going to be the first of a whole bunch of derivative rules that we're going to learn. So the first thing we want to do is recall that the derivative of a function tells us about the slope of that function. So remember, the derivative tells us the slope. Now before we found average rate of change, which was the slope of a secant line, so that was through 2 points. And with the derivative, we're actually going to end up finding the slope of a tangent line. So that's going to be through 1 point. So when we were actually finding that average rate of change, the slope of a secant line, we were using that to estimate the slope of the tangent line. So if you look at this picture here, we have a secant line, right? It's going through 2 points, and we have this line right here. So we would estimate that slope, or we would use that slope to kind of estimate the slope of the tangent line that really goes through 1 point on the graph. So you can see they're kind of similar, but this is obviously not as steep as this one. So we're actually now going to be able to find the exact slope of a tangent line. So to do that, we have a couple of different rules. So the first one is going to be the derivative of a constant function. So for all constant functions, if f of x equals some value c, c being a constant, then the derivative of f of x is equal to 0 for everything. So if you think about what the graph of a constant function is, it's just a horizontal line. So say c was -1, our graph would look like this, and the slope of that line is 0. It doesn't matter if I move that constant up or down, the slope's going to be 0 every time. So the derivative of a constant function is always 0 no matter what. Now here's our big rule. Here's our power rule for variable monomial functions. So a constant is a monomial, and we know the derivative of the constant is always 0. So if we have a variable monomial function, so something along the lines of a times x to the n power, the derivative of that is going to be a times n times x to the n minus 1 power. And that's going to be the basis for a lot of our derivatives. We're going to use those for a bunch of different things here. So what we're really doing when we have this is we are taking our exponent, dropping it down into the front, decreasing it by 1, and if we have a constant out here like a, then we multiply. So oftentimes we're going to think of this as drop and decrease. So we're going to drop our exponent and then decrease by 1. So we're going to be thinking drop and decrease for this rule. This is going to go hand in hand with our sum and difference rule. So for all differentiable functions u and v, the derivative of u plus or minus v, so that's how we would read this, the derivative of u plus or minus v with respect to x, is going to be the derivative with respect to x of u plus or minus the derivative with respect to x of v. So that's going to allow us to take the derivative of a polynomial and just take each term individually using this power rule here. So what that's going to look like, it looks a lot more complicated than it actually is. What it's going to look like is something like this. So find dB dt, so this just means the derivative of p with respect to t, t being our variable. So instead of having an x like we did a second ago with dx, we have dt because t is our variable. So find dp dt if p equals t cubed plus 6t squared minus 5/3 t plus 16. So we can say dp dt is going to be equal to. So if we think about this first term, it's a monomial with a variable in it. So we take our exponent, 3, drop it down front, have our variable, decrease our exponent by 1, and that's the derivative of the first term. So our sum and difference rule lets us do that same process, but for every single piece. So if we look at this one, so plus, I'm going to do this off to the side. We have that 6 that would stay, right? Because we said a times n times x to the n minus 1. So that a is 6 in this case. So 6 times drop your exponent, so 2 times t to the 2 minus 1 is going to be the first power. So 6 times 2 is 12t. First power, we don't have to write it, so it's just going to be 12t. Then we can think about this piece here. So again, I'll do this off to the side. We have an a value of negative 5/3. Drop your exponent. Your exponent was 1. T. 1 minus 1 is 0. So we can kind of simplify this a little bit. T to the 0 power is 1. 1 times negative 5/3 is just negative 5/3. And then we have to take the derivative of 16. 16 is a constant. The derivative of all constants is 0. So if you want, you can write plus 0, but that's not something we actually need on our answer because plus 0 doesn't really change anything. So the derivative of p with respect to t is going to be 3t squared plus 12t minus 5/3. So what we can do with this is we can use this to answer a question like number 2 where it says use your answer to find the slope of p where t equals 1. So if you were to graph this thing here and find the slope of the tangent line at t equals 1, that's what this is asking us to do. So I'm going to change our notation a little bit. dp dt does mean the derivative, but so does p prime. And if we want to find when, or what the slope is when x is 1, we can say p prime of 1 is going to be equal to, and now all we have to do is plug 1 into our function. So 1 squared, it's going to give us 3 plus 12 minus 5/3. So 15 minus 5/3, which is the same thing as 45/3 minus 5/3. So the slope at that point is going to be 40/3. So remember, the derivative gives us a function, and that function allows us to find the slope at any point here. So we got one more example, and then we'll stop this video. So does the curve y equals x to the 4th minus x squared plus 2 have any horizontal tangents? If so, where? So tangent line, remember, in order to find the slope of a tangent line, we want to take the derivative, but we want a horizontal tangent. So we have to think, what is the slope of a horizontal tangent? So a horizontal tangent is going to look like that. The slope of that line is 0. So we want to find when the derivative is 0, right? So the derivative tells us the slope. The question wants to know when the slope is 0. So we have to find the derivative, and when is that derivative 0? So we'll start with what's the derivative. So y prime, take your 4, drop it down to the front, decrease by 1, minus, take your 2, drop it down. 2 times 2 is 4. Decrease by 1, that's going to be the first power that we don't have to write. Derivative of a constant is 0. So there is our derivative. And the question wants to know when is the derivative 0. So we're going to set that equal to 0. We can factor out a 4x. And solve. So we're going to get x equals 0, x equals negative 1, and x equals 0. Those are all the places, oh sorry, not 0, but 1. Those are all the places where we have a horizontal tangent. So we're going to call it quits on this video. We'll see you in the next one.